Okay, bonjour, hello. Okay, so my name is Vivian. I'm a soil ecologist, and I've been looking at soils and helping farmers for the past 10 years. So it's allowed me to connect quite a few dots over time. And I'm good at yapping, so people invite me to come and talk. And today, I was asked to come and provide a speech that goes a little bit deeper into soil food web, soil ecology, living soils. These are all terms that I use synonymously, okay? In this presentation, I wanted to dive deeper into the mechanisms of nutrient cycling in healthy living soils in order to address the gap that we're seeing in the regenerative movement, where some people are transitioning to regenerative practices and seeing huge declining yield, where some people are adding in cover crops and still a few years in, they're still not seeing yield improvement. I think these are things that many people have seen, whether you're conventional or organic. Yep. Yeah. So I wanted to kind of address the why behind that so we can understand what is happening with the performance of our soils and to keep everybody from being discouraged and to stay motivated as they head through this regenerative journey. Oh, I'm also gonna take a second here to put my timer on because I have a reputation of going over time. Next, where do I point it? Oh, it's going. Here we go. Already did that one. Okay, the context of today's presentation. One, regenerative agriculture is on the rise. Yee-hoo! 10 years ago, it was an esoteric term, so good job, everybody. But as I said, there are many transition attempts that are seeing lower yields across the board. Why does one neighbor have this result? I'm doing the same thing. We have the same soil, but maybe not the same farming history. We're getting different results. Why is this? There's also harsh and punitive policies that are being implemented around the world globally on the use of nitrogens in agriculture, okay? We're gonna talk, without talking about this, we will address this. And my little note at the bottom, if we can close this right here, says, side note, let's get nuanced and not political, okay? The third is, I was asked to talk about soil life, and we will, because the heart of understanding all of these whys lies in the soil food web, soil ecology, living soil sciences. Okay, the keys to understanding the why behind these yield crashes and these differences. If I could get this mouse out of the way, it'd be so good. Okay, cool, thanks. Lies in this deeper understanding of soil microbial communities with specifically the nutrient cycling powers and functions of a healthy soil food web. There is a big link that we need to understand between a healthy soil, regenerating soil life and bringing back the natural nitrogen cycles of healthy living functioning soils. And in this, we need to understand how applied nitrogens, including organically approved nitrogen inputs, not just synthetic nitrogens, impact the regeneration of soil life. And this isn't to be judgy. This is just moving forward together. Okay. Whoops, request access. Damn it. All right. This is supposed to be a video of, under my microscope, a nematode swimming around, bacterial feeding nematode, eats bacteria. And we see a bunch of amoeba moving around. But just to get concretely, because we talk about living soils and it can seem kind of abstract, but this is what we mean. When I look under the microscope, are we seeing living organisms moving around, thriving, or are we not? It's as simple as that. Soils with living soils are soils with thriving microbial communities of fungal life and fungal networks connecting the plants, communicating and trading among one another. Soil animals and insects, hustling, bustling, and kind of dramatic. Sometimes we witness murders, but it's part of the cycle of life. An environment full of interactions and this richness. So when we are talking about regenerating soil life and the soil food web, this is what we mean. Again, access denied. I forgot to give access to the person whose computer this is. This on the top right is a video of an amoeba, which is like a soil cow multiplying through splitting itself. And here, down here is a baby nematode in its egg that is moving around in its egg that we can see. This obviously is the reproductive cycle of fungi in the soil. And traditionally, we've defined soil fertility as a combination of different nutrients and minerals in the soil. And while this is very important to have, nutrients and minerals don't have a sexual drive. They don't have sexual organs, and they do not reproduce. So when we talk about fertility, we need to be talking about the soil organisms. And so to keep this in mind as we shift our definition and shift our understanding together of what healthy living soils are. And regenerative agriculture, whoop, my speaker notes are gone. That's okay. Doesn't have a definition yet. We haven't agreed yet on what regenerative agriculture means. If we could get them back though while I'm talking, that'd be great, just in case. And seeing as it's the newest, hottest topic, I think it would be a good idea to start defining what that is. And I propose at least part of that definition should be that, let me take a step back here. Before regenerative agriculture was a trend, we were all talking about sustainable agriculture, right? But we were talking about sustainable agriculture because we had an agriculture where without intentionally, we weren't doing it intentionally, but we stripped the soil of its resources and it hit this low. And so we were like, hold on a second, we need to sustain the resources. Otherwise we won't be able to grow food. Well, I think that the reason why we're talking about regeneration is that it's not good enough to just sustain agriculture at this low point of degradation. We need to build resources back up. And so that's why I propose that part of the definition of regenerative agriculture be that it's an agriculture that builds resources and richness and life over time. It's very vague, but it's a start. And for me, the key part of that has to include soil life, because it is the soil organisms, along with the plants and the rocks that they erode over time and the plants that they decompose over time. This is how soil is built. Soil ecosystem is built through plants and microbes and their associations, breaking down the rocks, breaking down the organic matter, and storing that through time. And that's what creates soil. So this is why we keep coming back to the topic of soil biology and why it's becoming more important to understand the relevance practically in the field of something that wasn't so relevant in the past, which is the soil food web. So I want to zoom in to, this is a slide from my class that I teach. But we're just going to zoom in here. These are the ecosystem services and functions of soil microbes in a healthy living soil. And we're going to just zoom into this, which is all of these points. These are the tasks provided by a healthy soil community, soil microbe community in a soil. We're going to talk about this nutrient cycling aspect. So firstly, nutrients. Before we were all putting in minerals and fertilizers, organic, non-organic, a lot of people are doing this. Where are the minerals coming from? Where are the nutrients coming from? When it comes to minerals, we have rocks, okay? And over time, through a biological process of bacteria with their enzymes, those enzymes are breaking through the rock and breaking off tiny particles of rock and bringing them from this total form, which is in the rocks, down into this exchangeable pool of minerals. And this is happening through a biological process of bacteria weathering the rocks. Now, in this exchangeable pool, where do all those weathered minerals go after the bacteria munch down the rocks? They go into the fungal strands of the mushrooms. The mushrooms have tiny little microscopic strands in the soil that we call hypha, fungal hypha. And they're positively negative, they have positive and negative charge sites all over them, which attract any nutrient or mineral that happens to go by it, and it holds onto them on their bodies. And the bacteria hold on to nutrients as well, but this is the exchangeable pool of nutrients. And when we do NPK testing, we don't see this data. All we're seeing is what's soluble. And when it's locked into the bodies of the bacteria and the fungi, it's not soluble. It's not available to plants. But this is why we talk about the soil food web, is that their predators come by, they eat them. After we eat, everybody poops, and including microbes. And now we have soluble nutrients. We have soluble minerals. This is the mineralization process is biological. The solubilization process is also biological. This is how we get soluble nutrients in a soil ecosystem naturally. Secondly, once the nutrients in the soil, how do the plants actually take it in? Because the plant can't eat what's in the soil on its own. It can do photosynthesis, right? It can take sunlight, carbon, takes it in through its leaves, and it shoots root juices, juices down through its roots. Those juices we call exudates. But what does it do with that? Well, they use those juices to attract the rest of the soil food web. The soil food web, they want those root juices. Those root juices are concentrated carbon from the atmosphere that the plants are putting down into the soil. And they can get that by eating the root juices. And in exchange, the plants can get the nutrients that the fungi and the bacteria are accumulating in the soil. It's a carbon economy in this way. So there are three mechanisms, three ways of nutrient cycling that are microbial in the soil. Okay? The first one is the famous soil food web. We're going to talk about these one by one. The second is the mycorrhizal network. I'm sure you guys have heard the word mycorrhiza before. The third is the kind of new thing called the endophytic organisms, which just means the microbes that live inside the plant roots that the plants are actually farming. So the soil food web is like shopping local in the soil. The kick-starting chain is the sunlight. The plants doing their photosynthesis, bringing those juices down into the soil, or dead plant matter falling on the ground to decompose. The bacteria and the fungi, which are the primary decomposers, are decomposing that organic matter or are attracted to the root systems and taking in those juices. They're predators. The protozoa, which are the amoeba, flagellates, they're like the hogs and the cows of the soil. The nematodes, there are more beneficial nematodes than parasitic nematodes in a healthy soil food web. They consume the bacteria and fungi and release those nutrients that they accumulate either through weathering rock or by decomposing plant matter. So that's where all the nutrients, the minerals, the vitamins, how they get into the soil system. And then how they're released to the plant is through this predator-prey interaction. And then the cycle of life just gets bigger and bigger and bigger. And it kind of is the same as any biology predator-prey interaction we know of. The plant can consume the nutrients and minerals that are released through this predator-prey interaction if it happens right next to the root system. And conveniently enough, a lot of the time it is happening next to the root system because the bacteria and fungi are attracted to the roots to eat the juices. And so the predators are also attracted to the roots. And so a lot of this is happening around the roots. So that's one way that the plants will take up food. The second is in the mycorrhizosphere. So the type of fungi that I'm talking about in this poop loop is saprophytic fungi. Another jargon term for just it's fungi that grow in the soil. They create soil structure. They are different from mycorrhiza fungi. These are two different things. Saprophytic fungi requires a predator in order to release its nutrients to the plant. Mycorrhiza does not. Mycorrhiza lives inside the root system in a symbiotic relationship with the plant and does not need any predator. It's directly exchanging with the plant back and forth. And in a drought, where most of the predators in the poop loop they're aquatic organisms, the protozoa, the nematodes, they live in the water films of the soil. So in the drought, they go dormant. So in a drought, this mycorrhiza is key for nutrient cycling because this does not shut down during the drought. Now we're talking about functional diversity, not just diversity for diversity, but you're better to have less species that do different things than to have a lot of species that all kind of do the same thing, right? So the mycorrhiza, they're directly decomposing organic matter. They are piercing into rocks, and at the tips of their strands, they carry with them helper bacteria that they feed so that these helper bacteria, which are phosphorus solubilizing bacteria, et cetera, mine the rocks. Mycorrhiza pick up those weathered rock nutrients right away, send it right back to the plant. This is a second way that the plants eat. The third is the newest that we're discovering more and more about, which is that the plants are actually farming microbes, bacteria and fungi. Trichoderma is one of these fungi that at the root tip, they take in these bacteria and fungi. There's a superoxide molecule that the root blasts these microbes with that strips the microbes of their membrane, their outer shell. It steals a bunch of nutrients from them, including tons of amino acids, aka nitrogen, and clones them, and then they build up, and they get pushed out through the root hairs and spat back out into the soil. And this is why plants grow root hairs, because without this process, they won't grow root hairs. This is what science is discovering. It's wild. And they spit them back out with a type of saliva that tells them, hey, next time you come back in here, I need more molybdenum, or something like that, a shopping list. And it gives them food to survive out there so that they can rebuild their outer membrane. And they go through, they go mineralize whatever the plant told them to, and they go right back into the root. And isn't that wild? So, before I get to that nonsense, these are the three mechanisms and ways in which plants feed themselves with a healthy living soil. And every one of these microbes, just like a human body, has a carbon to nitrogen ratio. Our carbon to nitrogen ratio is 30:1. That means for every one nitrogen molecule that our body is made of, there are 30 carbon molecules. And that's what makes a complete protein, and that's how the human body is built. Every single microbe has a carbon to nitrogen ratio. What does this mean? The more microbes, the more carbon in the soil, but the more nitrogen available in the soil. I'm not talking about carbon today. We're talking about nitrogen. So this issue of transitioning and seeing huge declining yields when you're going from high inputs to lower inputs, or sluggish results when you're starting to implement agroecological principles, has everything to do with this right here. It's the nitrogen cycle. This is what it actually looks like in detail, but this is absolute madness, so I simplified it to this. Okay? If you want to go down the madness rabbit hole with me, sign up to my course and we'll go insane together. This is a simplified version of the nitrogen cycle. Our atmosphere is 75% nitrogen, right? Then there's nitrogen fixing bacteria, we all know this, that are in the roots. A lot of them are these endophytic organisms. That third mechanism of plants cloning, farming microbes, a lot of them are in there. Then the plants, the plants die. They decompose, or they're eating from the root juices. The predators come, they release that nitrogen as ammonium. It gets either taken up by the plant, and if the plant's not there to take up that nitrogen, nothing is wasted in Mother Nature. It goes right back into the bodies of bacteria and fungi. Nothing is just floating around for the rain to carry off into our rivers. Depending on the pH of your soil, this process will keep going, and the nitrogen will become nitrates or nitrates, which can be taken up by the plant as well, and whatever isn't taken up by the plant is taken back up by the soil food web. And in a soil that's regenerating and creating more and more microbial life with more diverse and abundant plant matter, this cycle, the reserve, the bank account of nitrogen, can you see how it will build up over time? More and more and more and more. And so that's what I was saying at the beginning, where we're talking about the details of soil food web, nutrient cycling, but the link between microbial remediation and the resuscitation of the nitrogen cycle. This is it right here. Whoops. This is it right here. That's what it is. So what does this, how does this apply to the reality of transitioning? What does this mean for management practices? What kind of actions need to be done? What kind of results can we expect? There's a lot of pressures to drastically reduce high nitrogen inputs on farmers around the world. And while we do need to do it, it cannot be done overnight, because otherwise it will mean detrimental results for farmers. And the reality is most farmers, even if they're organic, are using a lot of nitrogen inputs, whether that's pellets of chicken manure in organic. So you can't just pull that out, because you're going to have disastrous results. And why is that? It's because after all these years of tilling and excessive harvesting and not rotating and not having rest years or using products that are burning the biology, well, if you just take those things out, this nitrogen cycle is not yet restored. And so you're going to see declines. And this is the heart of, pardon me. Here we go. I'm missing a slide. But this here is the challenge of regenerative agriculture. This is it. How to keep the yields while regenerating the soil. And it all is to do with this. This is another slide from my class. These are all the actions that either kill off soil microbes or block the plant from feeding the soil organisms with its juices. How many of these do we do? All of them. Here lies the challenge of regenerative agriculture, right? Because nitrogen fertilizers and phosphorus fertilizers and minerals applied to the soil in a soluble form make the plants kind of lazy. When they have their food available to them just like that, they don't feel the need to spend that carbon currency, which is energy that it could use for many other of its functions that it has to do in any 24-hour photo period. It doesn't see the need to spend that currency on feeding microbes in the soil. And we need plants and diverse plants to bring this soil food web back. This is just a picture of plants that were transplanted into garden beds with organic nitrogen sources planted in each hole of transplanting hole. This was the starter mix of their mix of potting mix and compost. And then as soon as it gets transplanted into the soil with the organic nitrogen fertilizer, this clumping of soil around the roots is called the rhizosheath. And that's all the bacteria and fungi that are feeding off the plant juices. They have these glues around their bodies, gluing the soil to the root systems. And this is how you guys can see if your plants have these associations or not, if they've got these rhizosheaths. And here, it's not happening. The plant no longer sees the need in these new roots that grew since transplanting. And the majority of the research on plant agriculture that we have has been done with roots that look like this. So this is the current reality that I see in my microscope across soils, across provinces, across conventional and organic farming, is there's not much movement, there's not much life. Again, this isn't for shaming purposes. This is just the reality here. There's nothing, we're moving forward together. So this is why we are seeing sluggish results, even if you're doing cover cropping and it takes 5 to 10 years to start seeing these results. We might not have time as a farmer who feeds his family and pays his bills to wait 5 to 10 years to see these results. But this sluggish nutrient cycling is because it can take time for the soil food web to come back. And here we go. Here's a slide I was looking for. Here lies the problem, the heart of regenerative agriculture. And so we can't just pull the plug on these inputs. There needs to be a responsible transitioning plan. But it needs to happen. And I lost my train of thought. I shouldn't have looked at my speaker's notes. I had it. Anywho, the lag time. So the time it can take for a soil to regenerate really depends on one, the history of use. Have you tilled recently or have you not? How high toxicity is your soil? Aluminum, iron, copper, all these things. What's the salinity of your soil? Percentage organic matter. Do you have diverse plants? And what is your transition strategy? All these things will determine the lag time. It can be done in 3 to 5 years from really bad states if done properly. And we're seeing this even on scales of like 10,000 acres at a time. It can happen. And so if you are looking and thinking of your regenerative attempts or someone you know, we can use this nitrogen cycle, soil food web stuff we just talked about to understand the performances of our soil, not to get discouraged, but know how to move forward. These are actions which nourish and encourage soil life and plant microbe associations. What I mean by plant microbe associations are the way in which plants decide to interact with the biology or not, right? Not because the job has been made easy by adding minerals and nutrients in a soluble form directly to the soil, which either burns biology and or interrupts this photosynthetic feeding of the microbes, right? So these are all tools of regenerative agriculture. Probably you guys have heard of all or most of these before, but the key isn't one of them. It's not two of them. It's the synergistic use of these. Depending on where you're starting from, all of these might be needed. We can go slowly, integrate them one season at a time, but it's the synergistic use of them. Because I've heard a lot of people say, yeah, I've done cover cropping, doesn't work. Yeah, I've used compost, doesn't work. Okay, firstly, what's in your compost? Because that's a whole other topic. Because a lot of composts are not alive with all of these microbes, right? But it's not one thing. There's no magic pill. It's a system of things working together. This is a farm, 10,000 acres, corn, soy in Illinois, that my friend Todd Harrington, he's like the oldest soil ecologist on the block. His work is what Elaine Ingham used to promote her classes all these years. He's the original guy. His name's Todd, but I call him Nematod. If you ever meet him, call him Nematod and he'll know. But they started from, their 5th generation Midwest farmers, conventional. So you can imagine the state it started from. And I think units, they were well above 200 units of urea, nitrogen per acre, which is huge. And today they're under 100. And they did this slowly by every year, slowly reducing the nitrogen inputs, but not just reducing them, actively replenishing the soil food web at the same time. So cover cropping, using compost extracts, which are like compost teas, but way easier to make. And you don't need a microscope, and they don't take 24 hours, and they work just as good. And by using foliar mineral sprays. This, if you want to get out of the nitrogen loop, whether you're conventional or organic, and stop putting your minerals that you do need during the transition, you do have mineral imbalances. If you've got a microbiome that's out of whack, you're going to have a vitamin B deficiency. The human body is the same as the soil. So we need these minerals and nutrients during transition. But using them as mineral sprays, especially if you combine it with humic acids or fulvic acids or a compost extract, which has both, you can reduce the dose of your minerals from, you can use 10 to 30% of the recommended dose. It has the same impact. So there's a lot of waste when we put into the soil because the soil food web is not there to hold it in, and you wash your money drain away with the rain. And they've been using nitrogen fertilizers, but through mineral foliar sprays with compost extracts. And now they're not using synthetic nitrogens. So people are playing with soy concentrates. I know some people playing with alfalfa ferments. So we still have some playing to do. I don't have all the answers, just to give you an idea. But if you want to get out of this nitrogen loop, because if we keep putting it on the soil, you're going to keep interrupting the associations, and we're just not going to move. But we can't pull out nitrogen because we're going to have a crop failure because our soils are depleted. So we're hacking the system by putting mineral sprays, putting the nitrogen through mineral sprays, and then reducing as the years go by, because your soil food web is coming back. Are we never going to need any inputs ever again? I don't think so, because our agriculture is so extractive, but we can save a lot of money and have good yields and have way better ecosystem health by functioning this way. And Todd works with big farms who were organic. They were using a bunch of chicken manure just 2 years ago. Now they're not using any. It's all soil food web nitrogen. This is Jean-Francois. He's a farmer I work with in Quebec. 2,000 acres of cereal, corn and soy. 2,000 acres. Speed through here because I'm running out of time. He went organic in 2014. He was already agroecological in the sense that he didn't till, and he was already using diverse cover crops, but he was putting urea. And in 2014, he stopped putting urea. He didn't replace his urea with anything else. He just stopped putting urea. And then his yields went, bye-bye. And eventually he put some manures and stuff. He kept bringing soil experts from Quebec and France to look at his soil because his yields kept declining at more and more every year. He has rich organic matter between 4 and 8%. pH of around 7%. Land hasn't been worked in 19 years. The soil was not compacted, had good drainage, beautiful cover crops in the fall, everything to indicate that his soil was fertile and great, but he still had no yields. So when I got there, finally, in 2019, his harvest was well below break-even point. And he finally decided to call me, because most people have to wait a little while because they think I'm crazy when they first meet me, and then when they have to really be desperate, and then they call me. So this guy was desperate. And when I looked at his soils under my microscope, he had not much fungi, no predators. Like, you can have some, but there wasn't much. And there is a minimum amount we need for these ecosystem services and functions that the microbes provide there's a minimum number of these microbes that need to be present for the functions to start being delivered. And he didn't have that. His soil was chunky. He had an industrial smell, and I asked him, why does it smell like burnt tires? And he said, oh yeah, I forgot to tell you. I would put down 30 tons per hectare of paper mill sludge on my fields every year because my agronomist told me it was good to get organic matter. And I go, okay, that's some toxic stuff. His microbiome was in shock. Not his, but the soil. It was in shock from his plants were in shock from being cut off from its nitrogen source without having the natural nitrogen source. And then whatever biology he had was even further in shock from that toxicity. So we provided him with some compost, and this was the first year trial. This is down the line of the 10 hectares this way where he did a trial versus another 10 hectares this way where there wasn't a trial. This is, he started in the month of August. This is September 15th or something. These are oats. And you can see the dandelion mark down the line. That was enough to convince him something was happening with these microbes. This is him, oats with extract, oats without extract. That was enough for him. The next year he jumped all in, got himself a good extractor for making compost extract. We gave him the inoculum. He properly equipped himself to do it over his 2,000 acres the next season. I told him his soil was in intensive care, and he went all out. I have 5 minutes left. So this is just some of the, this is some of the extracting process. So he called me at the end of 2020. So in 2021 was the first year he did the applications everywhere. And huge yield bump, right? But caveat, not all of this is due to the microbes being present. Is that in 2020, he didn't harvest anything because it wasn't worth it. So there's so much more carbon to digest over the winter as well. But still, it's a huge increase in yield. This was the worst drought on record at the time. 2022 doesn't have that carbon bumper crop. This is just biology in his regular cover cropping cycle. And a few nettle ferments here and there. And still significant crop increase. And every year has been going up more. I think he texted me earlier, but I asked him to provide me the 2023 data because it didn't occur for me to ask him until I was on my way here today. But this is his case. He had lots of organic matter. He had lots of nutrients and resources accumulated in his soil, but it just wasn't turning. That wheel, that metabolism wasn't turning because that nutrient cycle is the soil food web, right? So in his case, that made all the difference. The guys in Illinois, they really had to do a lot of work to get to that point because they didn't have much resources stored. But this just gives you an idea of what I'm talking about today. This is in Toronto. It was a military base that they wanted to turn into an urban farm. This is after 3 years of diverse cover cropping. I think there were 14 plants, species integrated by a colleague of mine who I was working with from Wildcraft Permaculture. And over the 3 years, they were supposed to be doing one compost extract application just in the fall. And what I didn't know is that well, the field was separated by a ditch. And I didn't know that they were only spraying on one side of the ditch because they didn't feel like bringing everything onto the other side of the ditch. So at the end of 3 years, one side, and this is how I found out, it's because I go and I'm like, why is there a huge thatch layer here? And why is there a huge humus layer here? And they're like, oh, because we only sprayed this side of the field. We didn't want to cross the ditch with the truck. This is the power of the microbes cycling those nutrients, decomposing, right? But compost extract and compost tea are also, a lot of people talk about them as if they're the solution. They're not the solution. You can't just spray compost tea and compost extract and pull everything else out and expect to see results. I hear of farms having complete failures because of buying into that kind of rhetoric. It is a very powerful tool, but it has to be used in synergy with other practices. This is a bunch of yada, 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 yada. But basically, Jean-Francois is saying I've gone from being a farmer to an orchestrator of synergistic actions which together regenerate my farm. It's a symphony of life on my farm. I love that quote because that's really what it is. My friends have a market garden and they blast that with chicken poop. Great vegetables, but their cabbages are so fluffy and they have, of course, a bunch of insect pressure, lots of diseases. That's a whole another role of the soil food web that we're not going to get into today. But just this fluffiness. And it's apparently because the cabbages aren't picking up enough calcium, but their soils are full of calcium. So what's happening here? I'm sure some of you can guess. You can say it out loud. It's the biology that's not there to metabolize the calcium that's in the soils that the plant can't eat on its own, right? It's that plant that doesn't care to feed that relationship because it's getting fed. It's pumped on, plant pop. It doesn't see the need. So to conclude, the importance of soil life for regenerating the nutrient cycle, including the nitrogen cycle. This is the same for the phosphorus cycle and all the cycles. And the carbon cycle is of vital importance for successful regenerative agriculture. The reasons we see a lag time in yield return and yield declines is due to factors that might be slowing down the return of the microorganisms, such as the type of inputs you're using, toxicity that may have built up, salinity that may have built up, lack of organic matter, soil disturbance too, I didn't write that, lack of plant biodiversity, and that we need to keep this in mind in order to, one, manage our expectations, two, not get upset and discouraged, and to be able to adjust our transition strategies. Also, I hope this helps farmers and people involved in the ag decision-making process to understand why soils are performing the way they are. And I hope this will help people to understand the incredible task that farmers have at hand and are trying to figure out, because we don't have all the answers, to create policies that are constructive, helpful to farmers, compassionate about how hard this process is, encouraging and lending a helping hand at the same time. And I'm saying that because while I know that nitrogen fertilizers need to go, there's a transition, there's a reality to this, and I don't think it's okay to create punishing laws in this regard. I don't think it's constructive. And with everything going on, I think it's important to say that at this point. So I hope this is helpful to you, the point of regenerative agriculture for me is building intelligent, self-organizing, living ecosystems which build richness over time. And I hope that's the case for all of you. And that's the end of my presentation. Thank you.
Do you have time to answer a few questions from the audience?
Sip some tea while y'all have.
Okay. Maybe people who would like to ask questions, if you could line up at the microphones, I'll try to call you in order. As lots of people. Oh, and we'll also try to keep an eye on the Zoom. We don't have Dave here anymore. We've got Ashley. Okay, great.
Okay. I was interested, if I understood you correctly, you said spreading something like raw barnyard manure is in effect upsetting the soil nitrogen cycle. Did I get that right? Because I have a supplementary question on that.
Okay. What the animals eat impacts how their manure reacts in terms of this plant microbe association. If they're just eating good food that isn't too synthetically supplemented, manure is great for soil. Animals have always pooped on the ground, and it's been part of how the soil replenishes itself. I'm talking about industrially fed animals and that manure.
Okay. So that's where you were saying something like pelleted poultry manure from a conventional operation that may also have low level of antibiotics and that sort of thing. Because my supplementary was if barnyard manure is a problem, what about manure that's being dropped by the animals in the pasture? So
yeah, so barnyard manure is not a problem. Pasture manure is amazing.
Okay.
Regenerative grazing is key.
And do you have any figures on the relative nutrient capture of the soil by pasture manure versus the losses in that from barnyard manure? And I'll sit down.
Sorry, could you repeat that?
I think I've heard that there's some research that says that manure and urine dropped in the pasture by the animal, a lot more of it ends up being retained and available to plants and stuff that's collected in a barnyard.
Yeah, I don't have official figures on that, but from what I have seen and can just deduce, especially in a mob grazing context or an intensive grazing context, it's gradually dropped. And so it gives the microbes time to digest it right away and none of it's lost. It's also not fermenting to an anaerobic, very acidic state that can actually burn roots and burn microbes. So barnyard manure is great for making composts and letting the microbes in the compost to deal with that issue before putting it on the microbes in the fields, for sure. Yeah. Is that a okay answer? Yeah. Thank you. I guess we're going over there.
Great presentation. If we want to take your course, I'm guessing this is the contact info to.
Yes, it's coming. It's coming.
Okay. I had a question. I noticed one of the things you talked about was the use of like fungicides or fumigants and that really killing off your soil life. I wonder if you had any experience with farmers using plant like fumigants. So in my example, looking to control verticulum wilt, maybe through the use of, I know they're using mustards, really intense mustards, especially in potato production for controlling that. But I've always been a bit hesitant to go all out because I'm worried that that might also kill a whole bunch of other soil life inadvertently and kind of set me back and make me more disease prone, less resilient. Right. Do you have any comments on that?
So, I would love to see that in a research context that's actually looking at soil biodiversity. I can't tell you an answer that I know. I can't say I know the answer to that. What I know is that there are some fungicides that are worse than others. And I imagine a mustard-based, plant-based fungicide is less worse than others, because some of them not only impact the fungus that's there, but leave traces of things that prevent any mushroom from sporulating after the use. And I don't know the answer to that with plant-based, but I imagine it's not the case. It'd be something to look into. I do think there's a place for plant-based fungicides for damage control during transition moments, for sure. And especially if it's foliar applied and you let it do its work, and then after you come in with beneficial fungi through a form of fungal compost extract, I think it could be a really nice combination. But I think that's something that would be really cool to have farmer-supported research on. There's so many things that I'd like to see farmer-supported research on. That'd definitely be one of them. Yeah.
Sure.
Josh? Hello?
Oh, hi. Yeah, no one said I was talking, so you can hear me?
We can hear you.
Great. Yeah, thanks for doing this. If I missed this, because I missed the first like minute and a half of what you were talking about. I don't know anything about compost extract, and I'm just curious, the one example you showed seemed pretty high tech and for a large scale. What does compost extract look like if you're trying to put it on anywhere from an acre to say 20 acres? Like, how are we doing that?
Okay, great question. It's kind of like there's a voice of God coming down from somewhere. So compost extract is simply, you take compost. I don't even know where to look. Okay, you take compost and you shake it so that the microbes fall off the organic matter into the water. And that's compost extract. Compost tea is then you are putting in an air brewer, you're putting in foods into that extracted microbial soup of compost extract. And then you're brewing it for 24 hours to 48 hours. And depending on how much food you put in, the temperature, your altitude, that can either go really great or really bad. You need a microscope to be able to do compost tea to make sure it's good. And once you take the aerator off, the biology you achieved in compost tea changes right away. Versus compost extract, you're just extracting what's there. You can't mess it up. You don't need a microscope to make sure it's good. You just need to know your compost is good and your water isn't terrible. And you can't by accidentally grow bad organisms by overfeeding it because you're not feeding it. On a small scale, in my backyard garden, I put my compost in a little mesh bag. I throw it into a bucket. I vigorously massage it around for 3 minutes and it's done. On a 20-acre scale, we've put the compost mesh bag into a barrel or a tote and blasted a shop vac on reverse into it to do the extraction process and spray that out. You can do that on many, many acres because compost extract, you can use, the minimum you would use is 15 gallons per acre, but I think a minimum should be 30 gallons per acre. So it's very efficient. And then depending on how good your compost is, for every 30 gallons of extract, you're probably using like 5 to 10 cups of compost if your compost is really good. So we're talking efficiency here. But yeah, and then on a larger scale, you want to have an extracting system that can fill up your reservoir of whatever size you have. And that's just the difference is the tech. And what I showed in the presentation is the Cadillac of compost extractors, because he's brewing thousands of gallons a day. Yeah. Does that answer your question, Josh?
Yeah. Are there any other like easy resources to get a little more info on compost extract? Are they the ones on your presentation right there? Or where would we find something like
I
that?
have, there might be other people talking about compost extract or activated compost extract, which is another hack where instead of making compost tea where you're putting the nutrients in the water and then potentially messing things up, you're feeding the compost pile, especially if you're trying to deliver more calcium to your plants. You put little tiny bits to your microbes. They're going to hold those in their bodies that their predators are going to release to your plants. You put that out. That's activated extract. I have some free information on my website under the compost section about how to make compost extract, the difference between compost extract, activated extract, compost tea, and some basic stuff about equipment that you need. And in a few weeks, we're going to be adding even more info on that. So that's one place. I don't spend much time on YouTube or anything right now, so I have no idea what other people are talking about, but I'm sure there's other people. If you look up compost extract or activated extract online, I'm sure that there's other people talking about it. Sorry, I can't give you more than that.
Yes, I'm going to dream for a minute. How many hectares could you advise on? Because I thought it was a great talk. And then the second part, how long to clone a whole bunch of people just like you?
You mean like me having babies, or?
Well, whatever comes along.
That's one form of cloning. So the first question was, how many acres, hectares?
Could you look after as an advisor?
Me personally?
Yeah.
I don't know. I mean, the reason why I like teaching and like just giving this, I think there are a few people here who've taken my course, right? You took my course. There's a lot of information in that course, right? Did you feel ready to go when you took the course?
Like, to try.
Yeah. So at least that's a good start. And then working with local biologists to support that. The reason why I like teaching and giving this, someone's calling me. It's Josh. Oh, that's so funny. Is because I don't think one person can be enough to help all the amount of hectares that need help right now. And it takes a long time to get to the level of brainiac that I am, and hopefully there'll be more people over the years. But what I feel like is more important than training consultants, although that is important, and ecologists to support farmers, I think the farmers need to have this information, so that the goal for me, what I'm trying to do, is be as best as I can a good teacher and be among the people in this community that are supporting farmers as a scientist or as an ecologist, and that we keep talking with each other and sharing our experiences so that more and more hectares are under this kind of management. The thing about acreage or hectareage is it's just a matter of technology at that point, like having the right equipment for the scale. The principles remain the same, but the execution is really a matter of having the right equipment set up for your scale. After that, you know, if you're starting from a real state of degradation, maybe we're going to do further testing, like other than biological sampling and regular soil sampling, we might be doing SAP analysis to really get the system going. I know that's not really a good answer, but I mean, we can do a lot of hectares by having the right knowledge and the right advice. Probably lots. Yeah, if we work together.
You spoke to the seeds. You used the example of GM seeds being on probably this side of the spectrum in terms of their ability or their design to seek out that microbial exchange that happen otherwise naturally. Can you speak to the other side of the spectrum? What kind of seeds are especially desirable in terms of still inhabiting that ability as an heirloom seeds?
Yeah.
I'm a small ecological vegetable grower. So yeah, any tips on that side?
Yeah, that's a great question. GM seeds have been bred out of needing this association. And for every generation of plants, so that's GM seeds. And then there's regular non-GM seeds that have been produced in a conventional organic way that there might not be genetically modified, but they're plants that for many generations have not created these associations, or maybe have a little bit, but not to the full extent that they can. And like how a mother passes on her microbiome to her child, the plant passes its microbiome to the seed, to the next generation. So if the mother plant doesn't have that, but the mother plant can only pass on what she has to the next generation. So heirloom seeds that have been raised in this way for generations typically carry with them a much superior microbiome than other seeds for this reason, because they are used to not having synthetic or organic inputs, and they are used to feeding this microbial association. So yeah, the seeds that are used in regenerative agriculture do count. They really do count, especially for the endophytic microorganisms, that third category of microbes we talked about, where the plants are farming, especially those. And the microbiome, any of these microbiomes of the three we talked about, will end up being all over the plant surface, including the seeds. So it does give an advantage, aside from genetics, just microbially speaking. And microbes can impact the epigenetics of a plant. And so I hope that speaks to your question. I think this gentleman here was there, and then.
All right, thank you. I really enjoyed your presentation. Very interesting. And I love coming to these types of talks, but also I hate it because it makes me feel like I know less than I thought I knew. So my question's around compost. Many of us make compost. I know I've made lots over my career. I'm not sure how much good compost I've made. And of course, I don't have a microscope or a lab coat. But in your experience, are there things that you see with farmers making on-farm compost that, like, patterns of like bad habits or bad patterns, or are there some? I know there's no silver bullet. I'm not asking for a silver bullet, but I am maybe looking for a nugget of something that I can improve in my own doing.
Yeah, that's a great question. So yeah, generally farmer compost does not have enough brown dead carbon material in it compared to how much green material or as much compared to the amount of manure.
So more carbon.
More carbon, because carbon will feed more fungi. And it's not bacteria that are depleted in our soils. It's mostly fungi. And fungi are the pioneer species that pave the way for everybody else. Farmer composts, they're either too dry or too wet. And the carbon that goes into that compost, let's say if you're using like wood chips, a lot of people think of carbon, they think wood chips. The wood chips cannot be fresh. A lot of people are putting fresh wood chips. You got to let those wood chips age a year or two under the snow. 1 year is better, is great. 2 years even better. But if you got 1 year, that's great, because it will not break down if it's younger than that. And so the total amount of carbon being metabolized in the compost is not very much, even though you might have put a lot. So that's the thing I see a lot too.
Okay.
And yeah, just if the compost is too dry, if you take a handful, if you reach as far in as you can, take a handful and you squeeze, and you're not getting any water coming through your knuckles, it's too dry. And when it's too dry, those microbes are not going to work very hard, and you're not going to have a very good predator population in there. And when it's too wet, obviously we're getting some stinky stuff, and
yeah, it's anaerobic.
it's not good. Yeah.
So your comments about generally not adding enough carbon, kind of a related question, which is it possible to make good compost that's plant-based? Because sometimes I feel like the only reason for years I've said the only reason I have cows on the farm is to cycle nutrients and to create compost. But sometimes I think I should just sell the cows and then mow and chop the fields and compost, what would have otherwise been hay to feed these animals that are losing me money. So that's a long way of me asking, is it possible to make good quality compost without animal manure and using just plant-based, presuming that we were also adding carbon to that chopped material in the form of wood chips or a straw or something?
Yeah, you can make good plant-based compost. It's just trickier to get it to heat up to the right temperature. It's got to heat up to between 55 and 64 degrees to kill off any pathogens, weed seeds, on any of that stuff. Because manures are really good at getting to those temperatures easier. But you just got to play with your recipe and have a thermometer and figure that out. And yeah, I mean, chopping the hay for the animals can be degenerative for your fields. It can be a lot of work, and animals can use them on money, and it's a whole other day job to have them mob grazing in the field. Right. So yeah, there's some tough decisions to make there, but yes, it's possible.
Okay, thank you.
You're welcome.
Hi, Vivian. Thank you for your informative and wonderful speech. I have a question, and the soil degradation, I believe it certainly includes the soil pollution. And my big concern is pesticides, herbicides, and all those kinds of sites that may be left in the soil, and which may, this point has not been touched upon probably in your presentation. And I'm just wondering what types of green manures or like cover crops can help get rid of them. And if so, how they can get rid of them. For example, I grow alfalfa, and the alfalfa could collect those like maybe heavy metals in their body. But if I still leave them there to decompose, and then heavy metals will stay there, and how they will work if there are such like wonderful green manure? Thank you.
Yeah, that's a great and complex question. So there's one aspect, which is phytoremediation, using plants, like you're saying, the alfalfa. So there's some plants that, depending on what heavy metal is in the soil, not all plants will pick up that heavy metal and put it in their bodies, but some plants will. If you really want to get that heavy metal off your field, you would have to harvest that plant and take it off your field, if it is a plant that is accumulating, because not all plants accumulate all toxins. You would have to harvest all of that, take it off your field, bring it to an incinerator where they can incinerate that plant and just have a pure form of metal at the end of it. And that would be the cleanest job you could do. But that is an insane thing to ask of a farmer. I mean, that's insane. But I mean, if we're talking scientifically, that can be done. There are certain mushrooms as well that help. This is called myco. So we have phytoremediation, mycoremediation. There are certain strands of mushrooms that help accumulate heavy metals, but you're left with the same problem in the end, is that the mushrooms will accumulate those heavy metals and then you gotta do something with those mushrooms. And there's certain bacteria, and it's kind of the same thing over and over again. And I think the solution, I'm not sure what the solution is, but the more organic matter we build in our soils, the more humates we have in our soils, and the more that excess things like heavy metals and nutrients get locked into the humates and not necessarily picked up by plant life anymore, especially if that plant life has mycorrhiza. So the second type of microbe family I talked about. There are studies from, I think, Japan. I might be wrong, but there are studies of contaminated soils contaminated with heavy metals in market gardens. And they inoculated the plants with mycorrhiza fungi on one half of the farms. They did this on several farms, and the other half had no mycorrhizal inoculation. And the mycorrhiza helped pick up the heavy metals in the soil, but they locked them into the outer layers of the root system. So it never went up into the fruits or the leaves of the plants, versus finding the toxicity in the leaves or the plants, depending on the plant and depending on where they store and pick up that heavy metal. So I think a realistic solution for a farmer is to focus on biological diversity. And in this case, if you've got heavy metals, you really need to invest in mycorrhiza inoculation for your plants, whether that's on a large scale. When you're seeding, you're also putting out spores of mycorrhiza at the same time. You invest in a lab that is testing your root systems to make sure the colonization is happening. Again, like, there's so many reasons why we need farmer-supported research out here. This is another one. And to keep building the plant organic matter diversity and microbial diversity, that's over time building more organic matter, more humates that are also locking up the excess toxicity and preventing it from being brought up into the plants and then further contaminating the whole web of life.
Thank you.
You're welcome. Yeah, let's say 2 more talks because this voice is going.
Am I?
Yeah.
Okay. And then
Are you the Diane from the class? Hi, nice to meet you.
So we always hear aerobic, aerobic, aerobic.
Aerobic?
Yeah. And we heard a minute ago, we don't want our compost to go anaerobic.
Yeah.
But in your slide on the nitrogen cycle, there was an anaerobic phase.
Yeah.
You also talked about ferments in there, which are anaerobic processes. So I'm wondering if you can elaborate a bit on anaerobic for us, please.
Great question. Man, good questions tonight. Yeah, we do hear a lot about aerobic, and anaerobic. The truth in any debate lies somewhere in between. In fact, in soils that are too fluffy, aerated from tilling, too aerobic, we end up creating an environment that is favorable to very aerobic pathogens. And in soils that are too anaerobic, we end up creating the other spectrum of molds and fungal diseases. So from bacterial pathogens on the too aerated side to fungal molds and pathogens on the too anaerobic side. A healthy soil, so we can talk about composts too, but a healthy soil actually has what we call facultative anaerobes, which means facultative anaerobes are the microorganisms that can tolerate some form of lower oxygen, but not complete lack of oxygen. They can tolerate some form of aerobic activity, but not totally. And in this facultative sweet spot, we get lactobacillus, which is an amazing kind of natural antibiotic. All the cool Bacillus subtilis species that are really great at fighting diseases. And the truth is really well aggregated soils that are aggregated by fungi are creating aggregates that are bigger and bigger and that have less and less oxygen in the middle. And we need those environments because the nitrogen fixing bacteria need anaerobic settings to do their work as nitrogen fixers in the soil. And there are certain organisms that are super beneficial that are actually facultative anaerobes. So too aerated means we don't have great aggregation. If we don't have great aggregation, that means the fungi aren't there. If the fungi aren't there, that means the predators aren't there. If those big aggregates aren't there, that means the nitrogen fixers aren't there, and so on and so on. If we have too far the other way, or we're too anaerobic, well then the aerobic water species that we need that breathe, they're animals, like the predators, they're not there. And we need those guys. And some of the beneficial fungi they require some form of oxygen. So a lot of the most beneficial microbes actually need the sweet spot in the middle, not too aerobic, but not too anaerobic. And that's why in a compost pile, we need at least between 50 to 70, actually 70% moisture, which is when you take a handful and you squeeze, you get 3 drops coming out. A lot of people say you just need 1 drop coming out, which would be 50%. I actually find the better composts have even higher because of that fermentation process that is happening. And fungi consume a lot of water. But you need structure to have healthy facultative environments. So in the soil, that means you need root systems. You need the saprophytic fungi, the fungi of the poop loop, to act like rebar in the soil, holding all the bricks together, making big aggregates, creating the structures for air and water. We need that to work. In a compost pile, you can't just have a bunch of dusty stuff and have high moisture and expect to have good results. It's going to rot if you don't have material that has more bigger pieces of fiber, like aged wood chips, pieces of longer pieces of straw and stuff like that. So you need structure in order to achieve that sweet spot between anaerobic and anaerobic. Hi.
Hi, Vivian. I have to put a plug in for your course because intensive was an understatement. It was 4 weeks, 5 weeks, 4 hours every Wednesday. But the amount I learned was invaluable. And thank you so much. I do have a question. We have a market garden and we're trying to restore the fungal content from years of organic growing, but too much cultivation.
Yeah.
So we've totally stopped cultivation. The hard thing to achieve is the plant diversity you need to get the microbial diversity.
Yeah.
Do you have any clients or knowledge of people who are doing a good job of that?
Of more and more plant diversity.
In a market garden.
In a market garden. So the market garden group is the group I have least worked with over the years. I've mostly worked with large scale growers, and I'm just starting to work with market gardeners. The market gardeners that I do work with, I think they do speak English because we're in Quebec. But what they did was they started with a few species in one year. The next year, they added a few more. And they just kept adding over the years. And over the years, they ended up with a nice diversity and instead of trying to establish all of that in one go. You know, start with 4 species, which is a lot, actually. And then let whatever else come back up. Yeah, the market gardening thing, it's interesting because you think it'd be the group that would be the most advanced in this right now, but they're actually the group that I feel like we need to zoom in on the most right now because I haven't actually seen a lot of real life examples of regenerative market gardening. There's a lot of organic market gardening. There's not a lot of regenerative market gardening. In Quebec, I'm starting to work with 2 market garden farms, but last year was our first season. And what we've been doing, we brought in an agronomist who specializes in diverse plant mixes. And we did put in like a 9 mix cover crop, and it went really well. Perhaps if you really want, I could put you in touch with that agronomist. I can put you in touch with 2 of these market garden farms who are starting out this process. But I'm sorry to say that is the extent of my resources, and isn't that crazy? And isn't that crazy, right?
Well, the sticking point is harvest. Right? If you have a mixture of, we're trying for 4 functional groups and 6 to 8 species.
Yeah.
And you
in
can
your
get
beds?
them, you can get them along the rows where you missed one of your crop plants or something, but it's still an issue when it comes to harvest.
I mean, are you planting them, pardon me, just in the rows or on the beds too?
No, right in the beds.
You're probably in the beds.
Because how far do these fungi travel in a, it's a, how much, 90-day season? How far can the fungi travel to make connections?
Yeah, so it can take a couple seasons. Well, one, just in the rows for the first season with proper planting, proper inoculation. You grow the diverse cover crops until they flower. You let them bead and flower a few days before chopping them down, that kind of thing, right? It can take maybe 2 seasons, I'd say tops, if you're doing things right, for those microbes to get into your beds, right? Especially if instead of companion planting or multi-planting in the beds during the growing season. And again, I don't have the answers. We're like jamming right here, right? Maybe as you have your diverse cover crop in the rows, at the end of the season, once you're done harvesting, you put like a winter crop that winter dies that can help attract in the off season of your crops, whatever you've been cultivating in the rows, into the beds. and then planting in the beds without having that much competition. So it's not, it has to stay functional for you, right? And then mulching in the meantime to cover the soil, etc. Once you're done the harvest, planting something else that can continuously keep drawing the microbes into your beds. But yeah, we're getting into details here. She took my course, and so I don't have answers, but these are just some ideas. I didn't realize that you were doing it in the beds. That's amazing. So yeah, you had a hard time harvesting.
No, it's just the fact that you have to move when you're harvesting, right?
Yeah.
You can't be dallying around. So you don't want a marigold sort of half shading your lettuces that you're trying to pick.
Yeah.
But the results are phenomenal.
I'm sure. So what are you seeing?
So we're just experimenting.
Yeah. But that's kind of what we have to do. We need farmers that have the resources and time to play around a bit and experiment to figure it out. I'm looking forward to seeing your photos. What kind of results are you seeing?
Just the size these plants grow. I mean, the yield is
incredible.
Yeah, ask Daniel. There's some lettuces that are.
That's huge. And so
they're so big you can almost not sell them.
Oh my gosh. So the only difference is that you started integrating 4 or more different families of plants into and beside the rows, just everywhere, basically?
Well, we grow most of our crops from seedlings.
Yeah.
And use a Japanese transplanter.
Okay.
So there's always some gaps. So we fill it in with
your
something that gives us plant diversity.
You fill it in with your plant mix.
Yeah. Or just one plant here and there.
And the issue is harvesting because there's plants everywhere.
Right.
Yeah.
Right.
So that's the next step we can maybe talk about and figure out sometime together. But
yeah, well, I've got something to show you after we
I'm
finish.
so interested in seeing this, and thank you for being creative and brave and trying all that out. That's amazing. Wow. Isn't that cool? So in our class, we talk about functional diversity, which is a whole tangent, but cover cropping, just real quick. We talk a lot about cover cropping and have as much diversity as possible. But a lot of the time, we have plants that, many plants that do the same thing in the ecosystem. And that doesn't regenerate. 1, that doesn't bring much resilience. And 2, that doesn't regenerate soil life as much. And so what we were talking about and what Diane is saying is she's incorporated just 4 different plants families. So the more different the plants are in their taxonomical families, the more resilience you have and the more the biology works together between the plants and bounces back. Just a recap of what Diane is trying out in her market garden. I can't wait to see. Okay, we're good? Thank you.
Thanks again, Vivian. It was a real pleasure. So I'm going to wrap us up for the evening. Thank you for joining us for day 1 of the NFU-O AGM and Region 3 Convention. We will start tomorrow at 10:30 a.m., of course. For those of you not staying for day 2, please return your name badge in the box on the desk up above. And there's some packages of seeds that were donated that you can take with you if you like. Seeds donated by Hawthorne Organic Farm and some open pollinated tomato seeds donated by Kingston Area Seed System Initiative. So thanks everybody, and we'll see you at 10:30 tomorrow morning.